So today's lesson is a little different. I'm going to start out by going over last night's homework due to my having to be in some meetings, first through fourth period. So if any kids want to kind of look, I'm going to point out some things. Yesterday we did box and whisker plots. So we knew we first had to put them in order from least to greatest. We then had to go in and find our median in our data. Then we had to find our LQ, which was like the median of the lower data, and the UQ, which was the median of the higher data. Okay. Then we made our number line, usually about one lower than whatever our lowest data is and one or two higher than the highest. We made the end of our box with our LQ, the middle of the box with the median, and the UQ was 15, so we made that end of our box, connected it, and then our whiskers shoot out to the highest number and the lowest number. Okay, so this is number 1 off our homework. Number 2, you should have had the, lowest whisker of 11, LQ 12, median 13, UQ was 15, and the highest number 18. Okay. Number 3 should have had the lowest whisker at 32. 35 was the LQ. Median 37. UQ was 37 and a half. So look and make sure you got it in the middle between 37 and 38. And then your highest piece of data was 38. So that whisker stops at 38. Okay?
How many do you have to go like before you start?
Good question. 1 or 2 in front, 1 or 2 after. 1 is fine. Sometimes if I have extra space, I feel weird and I just fill it in. So, Matthew.
Okay, so on all of mine, after I did 1 and 2, I did every single, all the numbers above the question, so
I'm trying to think what you mean.
On this, after 1 and 2, when I did number 3, I did those numbers.
Oh, that'll mess you up. But it should go to a different number. Can you figure out which one it correlates with? No. Afterwards, I'll give you this, and then you can kind of compare. Let's see if that helps. Number 4. So kind of looking at number 4 here. We got lowest number was 21. Highest was 29. Median 24. And then LQ 22. UQ 27. Be very careful that these whiskers don't just shoot off the end of your picture. They have a stopping point. They have an exact number. Okay. Now number 5, I'm going to stop for just a second and kind of show you something kind of a little new or different. Basically with number 5, you should have had these numbers. So 52 is the lowest, 58 the highest, 55 median, 57 UQ, and LQ was 52 and a half, okay? I want to show you a few things that might help you out tomorrow or in your future, okay? I'm going to draw on this one. Here we go. Basically, I need you to know that between these first 2 dots, it is actually 25% of your data. Okay, now think about it. 25%. How many quarters are in a dollar? 4. There's going to be 4 chunks. Guess what? This is another 25% of your data. Now, granted, those are a little more spread out, aren't they? Okay. This is also another 25% of your data. And this is the last. That's another 25% of your data. So between each end of the whiskers, that's 100%. Okay. Sometimes they might ask you what numbers are in your lowest, the lowest 25%. What are in the middle 50%? Okay. The other thing is, I want you to kind of just know something real quick. I realize I've been calling this the LQ the whole year. It has another name. Sometimes they call it quartile 1 for quarter 1. They call this quarter 2, even though it's the median, it just has 2 names. And they call this quarter 3. Okay?
Where's the dollar?
Well, it's basically all of this is going to make your dollar, or is going to make your 4 chunks. That's the way they cut it up, because 3 cuts makes the 4 chunks. 3 slices make the 4 chunks. Now, they're going to start asking you questions like, what is the difference between quarter 3 and quarter 1? So you would have to look at what number represents quarter 3, what number represents quarter 1, and difference means subtract, okay? They could ask you the difference between the highest number and quarter 2. There's all different questions they can ask you, and you don't even have to make it. They might just give you a box and whisker plot, okay?
You said so 3 cuts makes a 4th? Well, I thought it didn't because it's
kind of like
right there.
Kind of like this. Like if you have a big, whatever, dollar bill. If I cut it 3 times, 1, 2, 3, it makes 25% or 4 chunks out of it. And it's kind of hard to see up there. Like to me, this is almost easier to see. Okay? My thing is, I need y'all to know that if I say the word LQ, it's the same as saying quarter 1. If I say UQ, it's the same as quarter 3. And if we say median, it is the same as quarter 2. Okay? All it is just different. It's different ways different mathematicians have labeled the same stuff. I wish it wasn't that way, but someone has to make it that way. So, let's check 6, 7, and 8 real quick. We got 6. We've got the median is 34. LQ 33. UQ 38.5. Highest number 39. Lowest number 32. Number 7. Median 51. Looks like 49.5 is that LQ, and 49. Think about it. That's 25% of your data. That's 25% of your data. It's the same amount of percentage of data. It's kind of weird. 58 UQ, 59 the highest. Okay. Number 8, I got LQ was 32.5. 32 was my lowest number. 34 median. Let's see, UQ 37, and my highest is 38. Okay. When I grade these things, if you have to create it, I'll use this as an example. There's 5 things I grade. I grade for is that point on the 11. I grade for is the end of the box at 13. Is the median at 15, and is the end of the box, as I call it, at 17. And then that whisker, did it stop at 19? I have to check for all 5 things. It's kind of like a 5-part question. Okay?
Okay, so why is it 13 and then it goes to 11? I thought it was 13 and then it goes to 12.
Where at?
Like,
You talking about here?
No, on the whisker plot.
Where at?
Right. Like
Here?
Yeah.
10, 11, 12, 13?
Where's the 13 and then it goes to the 11?
14. But that's a 14.
No, I thought it was like when you're done and like you go down 1.
Oh, now wait a minute. 11, 1 lower would be 10. Because see, I'm going from left to right on the number line. 10, 11, 12, 13. 10, 11, 12, 13, 14, 15. And then 1 up. You could do 9 or 8. It doesn't matter. Down here, you could do 21, 22.
I just did 12. So.
Oh, yeah. Now, 12, because your lowest number should have been 11. Does that make sense? So one lower would be a 10. Now, on the last one, number 10, checking this one. Okay. Now, I'm assuming from yesterday, if you were here, you got the box and whisker plot. You know how to find the median, the LQ, the UQ. You may have to review your brain in a day or two on how to recreate them, okay? But you should have your notes and your homework right there in front of you. Okay. Now what we're going to do is the new stuff. Today, we're learning mean absolute deviation. MAD. And it is not hard. It does have a lot of steps. And I will say, just like I've told the rest of my classes, this is definitely something that parents do not know probably how to do, because it is some newer stuff that has been added into the statistical world in the last few years. With that being said, that is why I am trying to do a video and make sure that you have something you can look back at. Now, I don't know. That's a good question. Now, basically, with mean absolute deviation, okay, we're going to start today with how do you just find mean absolute deviation. And then tomorrow, really get into reading what it stands for. It does use the initials MAD, or we sometimes shorten it to the word MAD. Okay? This is where I've been begging you to have a calculator the whole year. This is it. Here we go. Now, this worksheet talks you through exactly what to do. If you will look, it is great notes. Here we go. First, you were given these numbers, 50, 54, 54, 55, 59, and 61. They're already there, so it's kind of like your data set, okay? It is your numbers. Now, we need to start out by finding the mean of the data values. We need to find the mean of those numbers. Now, we found the mean last week. We got to remember how to do it, but how do you find the mean? You got it. Not divide by how many numbers there are. So, adding it up. Now, when I get done with my adding, I do usually write my total. So, like my calculator, I think gave me 333. And then divide by whatever it is. 6. Okay, I write that up there. So in case I mess up, I can make sure that I got, I guess you'd say, we can talk about why we messed up. So, yes, my mean is 55.5. Now, once you have the mean, you have the mean of your data set, okay? Look at what the next box says. We need the difference between each data value and the mean. Difference means subtract. So, look what we're doing. We're going to take our data. We are going to subtract out our mean, 55.5. Now, if we get a negative number, we are going to change it to a positive. So, minus 55.5 equals negative 5.5. So, what I'm going to do is, since it's negative and distance is always positive, right here in this box, I'm just going to write 5.5.
I still get it.
Okay? Listen, you're taking every data value, like 54. We got a minus, it tells you right here what to do, minus the mean. So, in your calculator, put 54 minus 55.5 equals negative 1.5. So, change it to 1.5. Okay.
Wait, why would it be that?
I'm not following you.
You've got to practice with me in the calculator. Type in 54, that is your data set, minus 55.5.
But it says negative 1.5, and you put positive 1.5.
That's because I said, listen, because it is distance on a number line, we're going to change it to a positive.
That's mine.
Okay?
That's mine.
Well, you don't keep it negative?
No, listen, I've said it. So, take 54 minus 55.5. Yes, and you're going to have a lot that are, that turn out that way.
So you just put in 1.5 and take off the negative sign?
Yes, take off the negative sign. Okay? 55 minus 55.5.
0.5.
Okay, 0.5. Okay, no, 59 minus 55.5. 3.5.
I'm still confused how you got the mean.
Okay, we found mean 2 weeks ago. How do we find the mean?
Add all the numbers up and divide it by the amount of numbers there are.
That's right. We added them all up and divide by 6. So that's the mean. Shh, please stop. We find the mean first, add it all up, divide by however many digits there are. Then we got to take the mean away from every number you have, every piece of data.
Okay, what'd you get for 39? 3.5.
Oh, that one, yeah, 3.5.
I got 3.5.
And then I got 5.5 on that one. Now, here's the weird part. You are actually not done with this, even though it's a lot of work so far. You have found the differences. Look what it says. The differences between the data and the mean. Now we need to average the distance. We're going to average the distance. Each data. Listen to me and I'll explain it.
Might be broke.
We're going to average it all up. Which what that means is we've got to find the mean of the blue numbers of each thing. Find the mean. 5.5 plus 1.5.
What?
We're going to find the mean of these numbers.
The minus that?
Yep, all these little blue numbers.
Okay.
Okay, I added it up. I got 18 divided by 1, 2, 3, 4, 5, 6. So my mean absolute deviation is 3.
Okay, now I have a question.
Okay, go for it.
Okay, so how did you get 18? Because I was getting it until the 18 part.
18 was from me adding up these little numbers.
Oh, okay.
Okay, and here is the hard part about this. If you are off by one number, it's going to throw it all off, especially if your mean's wrong. So that's why when I go through and I write, like, I kind of do this, because if you miss the mean, you're going to miss the whole thing. And then I keep writing it down. Okay, the arrows are taking that mean. Oh, over here? Okay. This sheet was originally made for a fellow teacher of mine that used to work at Oak Mountain. It ended up being a real good, helpful thing today because I had to have a substitute in here for a couple hours while I had some meetings. And since the sheet kind of tells you what to do up here, it actually worked out really good. But the reason there is so much space here is because at Oak Mountain, they weren't allowed to use a calculator. So they had to take 50. They had to write like 55.5 minus the 50 and get the number. Then they had to transfer the number over here, add them all up, and divide, and no calculators were used. So, well, here's the deal. It matters. We get to use a calculator because we are practicing for our standardized test where we get to use a calculator. So we're lucky enough to times have changed, and we all get to use one.
Is it
okay?
Now to use them?
I don't know. This is just something I received.
How old is this?
Oh, it's not old. The person used it last year. So, here we go. Now, let's do another one. This one called Afternoon Temperatures at 2 p.m. Now, so think about it. These are some temperatures, 65, 71, and so on. First, we want the mean of the data values. So we're going to go in, the mean. We got to add them up and divide by however many there are.
$4.50.
Okay.
75. 75. Oops.
Okay. Now, my mean is 75. Now, we're going to put 75 in for each little subtraction. Now, please don't guess at these if you are not sure. You have a calculator, you might as well use it. And what I call get the right answer. Okay, so we got that right. Now we're going to subtract it. So 65 minus 75 is negative 10, which is 10. 71 minus 75 is negative 4, because my calculator says negative 4. But I'm going to change it from a negative to a positive. 74 minus 75 is negative 1, so we'll make it a 1. Same thing for that one. 82 minus 75 is 7. Sorry, not negative 7, but 7. And then 84 minus that is 9. Now, so look what it says. Average it up. Teachers average your grades. So, we're going to add up all those little boxes.
It is something. I got it.
It's 32.
It's something.
It's 32.
32 divided by 5, 6. Divided by 6. Now, I need you to be able to either put 0.33 or 0.3 repeating. Stop, guys.
I just put 5.33.
That is fine. That is fine. Now, basically, tonight's homework is to finish. There are 4 more of these. I'll give you on a piece of paper, and you're going to work them out.
Oh, wait, really only 4?
Here we go.
Really only 4?